Hello, this is Mr. Hu. Welcome back to QuickCalc, and today we're going to learn a very important unit, 1.4 continuity, in chapter 1. This is going to be tested every single year in the multiple choices. I even remember there are 2 years they make some proving questions in the free responses for this type. So very important unit, all right? And first we need to know the definition. I'm just going to read quickly. All right, FC is defined. Limit on the C point exists. Define, exist, and that's important. The limit value actually equal to the function value. You have to fit 3 conditions. We can call that continuous at C. Very conceptual. But later I'm going to use 4 different graphs to show you 2 types of discontinuity and the 2 types of continuous on the entire real numbers. Okay, so I think most students are like visual learners. That's what my experience is. Okay, so let's take a look. First one, fx equal to 1 over x, fundamental functions. So some graph look like this. We can tell here x is not defined or undefined at 0. So that point, we call that non-removable discontinuity at x equal to 0. This is non-removable discontinuity. Okay, it's hard to. All right, and the second type, of course, we're gonna talk about removable discontinuity. So before we draw the graph, let's take a look here. We can simplify, right? We can simplify x plus 1, x minus 1, x minus 1. Oh wow, we can cancel the top and the bottom, but wait a second. First, we need define x cannot equal to 0, otherwise what? It's defined. So now we can cancel it, x plus 1. Alright, so the graph look like a straight line, but cannot equal to 1. So there's gonna be a circle and this. So this point x equal to 1, yes, it still make this equation like what? Undefined, but it can be canceled the top and the bottom. We call that removable discontinuity. Just think about it, right? Non-removable means you can do nothing about it. So it's non-removable. And then removable means, oh, actually you can simplify. You might not see this point at the domain, but actually it's undefined. So you can feel the difference between the first one and the second one right here. All right. So this is the non-removable. One is removable, and the other 2 are the typical equations are continuous. This is a piecewise. All right. Even it's a piecewise, it might look like a little bit weird, but it's still continuous. So when we check if it's continuous or not, we just check if any point has a circle, empty, right? Is this any part like a disconnected? If it's not, all right, this continues. Just that simple. All right. What about D part? It's a sine function, something like this, right? Keep going. And oh, sorry, it's a little bit too crazy. Okay. So yeah, every point connected. There's no empty point. So this is also continuous. All right. Thank you for watching.